All right, students. So what we're going to do is demonstrate how to check that actual battery for the starter circuits. We're going to look at both the voltage drop that we're seeing out of the battery, and the current draw of the starter on the system, which would be the first step after we verify that the battery is indeed fully charged and able to hold a charge. Now we're going to go and see when the starter actually tries to crank over the vehicle, if we're actually getting the correct current draw out of the starter and if the battery is able to sustain the load. Now, very important, one of the very first steps I'm going to do is I'm going to go to the trunk of the vehicle, and I'm going to go back there and I'm going to pull out the fuse for the fuel pump on this car so that it doesn't start. And I'll show you how we're going to set up our 2 meters on the vehicle, one set up for voltage and one set up to measure amperage. Okay, so the first thing that I'm going to do is start in Pro Demand. I've already entered the vehicle in, but we can see that right here. I did it by VIN number, so we'll go in here. And because I'm going to be doing a test of the starting system, including the battery and starter, I want to disable the fuel system. So what I'm going to do, I'm going to start out in the wiring diagrams, and I'll go under the system wiring diagrams, and I'm going to select engine performance in this case because I know that the fuel is most likely going to be involved there as far as feeding the engine the fuel. So I'm looking through here, and I'm just going to kind of get myself oriented with the schematic. Again, usually towards the top we'll find our power supplies. One of the things, we're going to scroll down here and kind of look over the menu. Oh, look at there. We got a fuel pump control unit involved in this car. And it looks like it's this is what's controlling the fuel pump based on inputs from the engine ECU on this vehicle. So as I had mentioned before, some of our numbers that I try to pay attention to, the 30s are indicating some kind of power supply for this control unit. So what I can do, I can click on that particular wire here, right? That'll cause it to highlight. Looks like I've got another one highlighted by accident, but we look here. I'm just going to highlight this one. Oh, and it seems like it runs back. That's okay. And based on that, now I can kind of go between the wiring diagrams, see if I can chase where this 30 power supply is coming from. I will go over to the next page here, and you can see it's highlighted here. Oh, look at that. It's running right up to this fuse 42. Looks like a 20 amp fuse, and it's telling me rear CAM control unit with fuse and relay module. So it gives me kind of an indication where I should find it. It says left side of the trunk cargo area. All right, well that's good, right? So now we know where to go look. We're going to be looking for fuse 42, indicated by the number underneath the fuse, and then it says 20 amp. So that's good information to know, so that we go back there and disable the fuel system so the car won't start so we can perform the test. Okay, so now I'm back in the trunk area. There's this kick panel that's back here. Just drop it out, and I got my fuse box. Again, we're dealing with a Mercedes, so every car will be different. I've already gone to the schematic and located that the fuse number is a 20 amp in spot number 42. So I took a close look here at the fuse box itself, and you can actually see there's numbers. They're very finely printed. You got to look really close. But the relay ID, or the fuse, I found was this 20 amp down here. And what's kind of important about that is I'm just going to set it aside. That way we don't start the vehicle. But this particular fuse box on this car is actually a control unit as well. So it serves a bunch of different functions on this car. But this fuse will become important later on in your learning, because if we wanted to look at, for example, the draw on the fuel pump and actually take a look at the health of the fuel pump, this is where we might want to put in a loop to actually watch the current being drawn by the fuel pump. But that's another lesson, so let's keep going with the starter. Okay, so I've got 2 meters with me today. Take a quick look. In most cases, both of them I'm dealing with are flukes. In this case, could be any type of of meter that can measure amperage, or in this case actually just needs to measure voltage. So this one I've got an actual amp clamp, and you'll notice there's a set of jaws here that we can actually measure the amperage draw. This vehicle is pretty easy to access because the main wire for the starter lead runs down here right along the side, so I'll be able to get my amp clamp around it. Now they do make bigger amp clamps. I'll show you another one later with a bigger eyelet for vehicles that have a more wire looms tied into it. So two different meters here, and what we're going to do is on the meter that we're going to measure voltage, we're going to use this one. This one's a Fluke 189, if you guys are curious. This is a what they call an RMS meter, so they're a little different style on how they figure out the voltage, but in this case, for what we're doing today, it's not going to be a huge difference for what we're looking for. Now keep in mind, one of the things that you guys will learn about is sample rates, and these meters have limitations as far as how fast they can sample, but again, for what we're doing, we're going to get a pretty clear picture, and I'll show you how to get a finer picture, but let's just take a look. So first of all, I'm going to put my red lead on the positive terminal of my battery and my black lead on the negative side. I'm always checking the battery to make sure that I indeed have a good positive or negative mark where I'm hooking up those wires, because sometimes the colors are not the way to go. Sometimes people will change it. So this one's set to DC volts over here. One of the nice things that I mentioned to you guys about this style meter is that we're getting an actual voltage reading right now. It looks like it's dipped a little bit, probably because I was in the back and had the doors open, but we're at about 12 volts. We're just going to run it that way. Normally we'd want to see about 12.6 there, but I'm going to hit the min-max function on here, and what that'll do is it's going to record any voltage drops or spikes that happen, the minimum and maximum voltage. On this meter, I'm going to set this one to millivolts, and the reason for that has to do with how an amp clamp works. This one is set up to measure in millivolts, and every increment or amount of millivolts that we use is marked here on the actual amp clamp. So this one shows you 10 millivolts per amp. 10 millivolts is equal to an amp, up to 60 amps. Now this clamp is a little underrated for what we're doing here, but currently this is all I have with me, so I'm going to show it to you this way. And then we're going to set this to millivolts on this because we want to measure the millivolt of the draw. I'm going to hold my clamp down here, and I usually want to zero it somewheres around here. There's a little zeroing mark that actually gets it on the zero. I'm actually looking at the current position in this case, which is marked by an arrow. I know the current will be flowing this direction, and I'm zeroed out. I'm also going to hit the min-max function on this as well. I've got both meters set up now to record. So now I'm going to step over here, and we're going to crank the vehicle up. And this is nice to have that minimum maximum feature, because if I didn't have a secondary person here, it might be hard to see what's going on. So I kick the key on. I cranked it over. And now the good news is that it has actually recorded the values on my meter. So I'll be able to actually see here what I've got. So if I go to this meter and I hit the min-max function on here, I'll see that my voltage drop on this came down to 10.19 volts, which would probably be considered in most circumstances on vehicles healthy. Over here, I'm going to go and look at the min-max function on here, and I'm going to get it on max. And the max exceeded the limit in this case. So I'm going to have to use a different clamp in this case, since I don't have a bigger one, which is going to require that I take out a scope. But just getting a general idea, this this would have measured up to about 60 amps, fairly healthy. So it's exceeded that. We would expect that, because typically we're dealing with a V6 engine. We should be looking at somewhere above 125 to 200 amps, depending on how we find it on our chart. So let me stop right there. That will get us set up with a different measuring tool that we can actually get a very accurate measurement of what's going on here. Okay, so what I'm pulling out now is a tool I'm really excited to have. This is an oscilloscope, so this isn't something you'd have at home. It just happens to be that I have an amp clamp that's large enough. This is the new Pico that's out there, and I'm super happy to have it. Not sure my wife is for the price of it, but this is a really great tool in what it does. It's a PC based lab scope, and probably one of the best on the market. If you were to go out there and kind of look through the industry about what's available, doesn't mean that there's other scopes that wouldn't do the job, but this one is specifically a very powerful tool. So anyways, I'm going to hook this up to my laptop here, and got logged in, and you'll see here I've got this bigger amp clamp in this case. So I'm going to get this over around my wires. This gives me a little bit more play. Again, there's an arrow that's marked on here. That's right on the end. That has to do with the current flow. So I'm going to hook that up, and then set up here, get my software opened up as soon as my laptop catches up with me. Okay, one of the nice things about Pico is that it does come with pretty much what I consider error-proof information. It pretty much sets it up and tells us exactly how it wants us to hook up and pay attention to certain values in here, which is be really handy. And then give you a whole assortment once you guys learn more about electrical on exactly what kind of sensor we're hooking up to and how to test that particular sensor, which can be really nice. And I know you guys can't see this right now, but I'll try to get you a better view of this. But I'm going to go up here, go under automotive, charging and starting circuits, current versus volts, starting. And then what this will do is open up and give us a basic description of how a general system works, and then how to hook up to this particular system that we're trying to test. It's showing me here on there's different channels on a scope, and again, I don't expect you guys to know that, but you basically, this is a 4-channel scope. We have 4 channels. So I'm going to go ahead and hook up my first lead, and then my second lead. Now what this is doing, this tool is able to measure both amperage and voltage. I could actually measure 4 different circuits at the same time if I really wanted to, but in this case we're really focusing on the same 2 tests that we were doing with the 2 meters. So I'm going to go ahead and hook this up to the battery. We're going to get some values in here, and then we're going to take a look at this guy. And at this point, all we want to do is start the scope here, and this is set up with what I call a trigger. So this will actually record that sample, and I know you guys can't see it, but I'll try to get you a screenshot of this one. Briefly, let's take a look at the wiring schematic for this vehicle, in particular the starter circuit. You'll notice at the bottom we have the starter, and in the middle there you'll notice the battery. Let's follow the voltage that comes out of the battery down to our starter as it works its way through. What we're trying to measure is that current flow. So we're going to use our amp clamp. We're going to clamp somewhere on that wire where we get the wire through the eyelet, so that we can monitor the actual current flow. Now, let's talk about voltage. We've got to hook to the battery, our positive lead, and our negative lead, and then we're going to try to measure voltage. We could use a voltmeter or an oscilloscope. Either case, we'll be able to monitor both the current and the voltage being consumed, or the voltage drop of the battery and the current flow to check the health of the starter. Okay, let's look at a scope. On the left side, we have the amperage readings. You can see here the line indicates the 0 mark, and as amperage goes up, it increases steadily up to 600. On the bottom, we have the time scale. This is all the time going across this pattern. At this point, we can see 1 second of time has passed. And at this point, we can see about a half a second of time has passed. On the right side, we see the voltage scale. We can see as voltage goes up from the 0 mark, it increases up to a maximum of 20 volts. Looking at the top, we will see the left side top is channel A, indicated in blue, and so is our pattern across the graph. On the right is our B channel, indicating our voltage reading. At the very top, we see the peak of the amperage, which in this case was 487 amps. And we can see that the red trace came down to 8.297 volts under a load. Okay, because of the sample rate of the scope, we have to pay attention to what we're looking at. So we're going to try to look at averages. We can see that the average of the amperage draw on this was around 150 amps. We know that our voltage dropped on the battery to 8.29 volts, but again, we want to pay attention to the average, which is the line slightly higher here in this case, which worked out to just about over 10.2 volts, which is what we got with our voltmeter. So I hope that gives you a good indication of what we're talking about when we're talking about voltage versus current in diagnosing the starter system. Obviously, we see the amperage is much higher and the voltage drops heavier on the initial startup. If the amperage had gone much higher or much lower, we know our spec for the vehicle, for the current draw, and for the battery, we could determine if the battery actually had a problem or the starter might have a problem, or some of the electrical wiring in between might have had high resistance. So I hope you found this helpful. This should have given you a good, clear idea of current versus voltage when diagnosing a starting system.